are now on day 19, I believe it is. Time is flying, and we're going to start Unit 3. So we have about 30 days in each term, and considering we're on day 19, that might tell you that we're getting close to the end here. Pretty fast. It goes, we're almost there. One. Sorry, guys. Algebra 1. My brain, it's on another level today. So Algebra 1, we are now in Unit 3. And because we are starting to get near the end of Algebra 1, we're going to start getting prepared to move towards Algebra 2. That being said, we're actually going to do the opposite of what you might think. We're going to be going back to the basics and making sure that we understand all the algebra concepts that are going to be used when we go to the next level. So I'm going to go ahead and just name all my pages. This is our day 19 notes. And it is Wednesday, April 23rd. Okay, and this will be page 1. So we're just going to run through a few of the basic concepts that we need to understand and get them in our notes so that we can look back at them. And the first thing that we're going to talk about today is like terms. Like terms. So, like terms, I'll give you a definition beside it, are numbers with the same variable and exponent. First of all, what is a variable?
Ain't that the small number over the top of the big number?
Backwards. That's an exponent. You're correct there. Variable is a little different. Anybody know what a variable is?
X or Y.
Your X, your Y, your Z, your Q. It's a letter that represents a number we don't know. But you are correct in saying that the exponent is that little number that goes kind of above. So we're going to talk about what like terms are. For example, let's see. If I have 3x and 3p, are these numbers connected to the same variable? No. So are these like terms? No. These are not like terms. What about 15x plus 6x? Are these like terms?
Yes.
Yes. So if they are like terms, they have the same variable, then we can add and subtract them like normal numbers. So if I were to add 15x plus 6x, what would that give me? 21x. Perfect. 21x. Good. Those are like terms. We can add them. What if I gave you 5x squared? 5x to the second power. Here's our exponent. plus 3x. These are not like terms. Why are these not like terms? Yes, only my first term has an exponent. Even though they both have an x, they don't both have x squared. So whenever we have an exponent attached to our variable and the other one doesn't, these are not like terms. We cannot add or subtract them. So let's try something a little different. What if I have 4x squared minus 2x squared? Are these like terms? Yes, they both have x squared. X squared. What would 4x squared minus 2x squared be? 2x squared. We just take 4 minus 2 and we get 2x squared. Perfect. Perfect, perfect. Okay. Now let's look at what would happen if we have more than just two terms. For example, let's say now we have 4x squared plus 6x minus 2x squared plus 3x. Stepping it up. 4x squared plus 6x minus 2x squared plus 3x. Now we have 4 terms. But which terms are like terms? Yes. Yes. So we have first 4x squared, and my other term with an x squared is that minus 2x squared. So I'm going to group those by using the same color to show that these are like terms. I'm going to draw a little line to connect them. And going to the next one, I have 6x and 3x. These are like terms. So now, what do you think we would do to simplify or put together the terms that are like versus not like? How would we go about? Yes, we're going to combine them. So I cannot combine any of my terms with x squared. These do not go with x by itself. The x squareds go together. So let's start by just looking at x squareds. I have 4x squared. I have minus 2x squared. So let's see. Let's write these out separately. I'm going to write 4x squared minus 2x squared. What is 4x squared minus 2x squared? 2x squared. So I've got that. And what do I have left to do? Good, the 6x and the 3x. And what is 6x plus 3x? 9x. So now we have 2x squared and 9x. If we wanted to write this as an overall total answer, we can't add these together, can we? Why not? Because they're not like terms. They don't have the same exponent. So our answer, because we cannot combine them, we just put a plus in between them. We have 2x squared plus 9x. And that is as far as we can go. That would be our answer. Okay. Now I'm going to write one out that I want you to try on your own. How about 6x to the third power plus 2x minus 3x to the third power minus 1x. Okay, I want you to solve this, or not solve it, we're going to simplify this by combining like terms. I want you to try this one on your own. I'll pause our recording, give you a minute or so to do that, and then we'll look at the answer together. All right. How do I solve this? How do I simplify? Let's combine our like terms. So starting with the first term, 6x to the third power, what else is a like term with this one? 3x squared, 3x to the third power. My bad, I misspoke. We both misspoke. 3x to the third power. How do I combine those? Am I adding or subtracting? I'm subtracting. Why? Yes, because there's a negative sign in front. You're okay, you're okay. Don't worry about it. So let's start with that. 6x to the third power, make that a little thicker, minus 3x to the third power. And what does that give us? Yeah, 3x to the third power. Okay. What else do we need to do? Yes, my 2x and my 1x. And we combine those by adding or subtracting? Subtracting. Why? Yes, that minus, it tells us we're going to do 2x minus 1x. So that gives us 1x. 1x. So how would we write our answer? Perfect. 3x to the third power plus 1x.
You can also write the 1x.
Yes, you could. You could also write 3x to the third power plus x. Because
X is always going to be like 1, right?
yes, always, always, always. Perfect. So these are our answers. Either one is good. I will take them both. Okay. How do we feel about like terms? Do we have a good understanding? Good. Good. So with like terms, the basic rule, this is only concerning adding and subtracting. Only adding and subtracting. When we move to multiplication and division, we can multiply and divide anything. Believe it or not, we can. So let's go to the next step. And we're going to talk about what happens when we start multiplying and dividing, especially when we have exponents involved. That's where it gets tricky. So I'm going to title my page once again. We are in Algebra 1, Unit 3, page 2. day 19, notes, continue. Did I put that recording back on? Yes, I did. Okay. So we have covered like terms. We know we can add and subtract them only if they have the same exponent or the same variable. So now let's cover something that we call distribution. I bet y'all remember this. Distribution. Distribution. Distribution is whenever we use multiplication. Multiplying each term in parentheses. So for example, if I have 5 and directly beside it in parentheses, I have x plus 3. I will use distribution to multiply 5 times x and 5 times 3. So the first example, I will show it to you like this. And really what we're doing is 5 times x, bring down my plus 5 times 3. And what is 5 times x? 5x. Bring down my plus. What is 5 times 3? 15. Good. And that would be our answer. So there's our first example of distribution. Let me show you another. What if I have -3 on the outside? And in my parentheses, I have 2x plus 4. What would I do here using distribution? Perfect. I'm doing -3 times 2x, and I'm also doing -3 times 4. Okay, bless you. So let me draw my arrows. I think sometimes those arrows help us visualize it. So what is -3 times 2x? -6. What am I missing? X. Good. Okay, then what? Plus -3 times 4 is -12. How else could I write this? Yes, I don't need to put the plus there. I can just write -6x minus 12. Just like we talked about way back in pre-algebra, adding a negative is the same as subtracting. Adding a negative is the same as subtracting. Good. Now, what if I had, here's another, -2, and I'm going to distribute that into -5x minus 3. Negative 2 times negative 5x minus 3. What's going on here? We're going to multiply. First, we'll multiply negative 2 times, yes, that'll make us get positive 10x. Good. 10x. And next? Yes. Negative 2 times negative 3, positive 6. So we skipped the writing out each step part here. We went straight to the answer. Does this make sense to everyone how I got here? Perfect. Perfect. Okay. How do we feel about distribution? We feel okay? Good. All right. Now, let's start talking about exponents. This part might be new for some of you. It might be a review as well. I don't know what all you've been exposed to. So we're going to move on down. And the next section, I'm going to title this Exponent. Multiplication. So let's start small. First, I'm going to tell you this. X times, and I'm going to use the dot as my multiplication symbol so that we don't mix it up with another variable. So I have x times x. Does anybody know what x times x would equal? X squared. Yes, x squared. Good. What about x times x times x? Yes, x cubed, or x to the third power. Yes. What about x times x times x times x? X to the fourth power. Do you see the pattern? However many times you are multiplying x by itself, that is the number for your exponent. I multiply it twice, x to the second. I multiply it 3 times, x to the third. Multiply it 4 times, x to the fourth. You see, it's not too bad. Here's where it gets tricky. What if I did x squared times x? X squared times x. Any ideas of what our new exponent might be? Yes, x to the third power. How did you know that? Yes. Yes. So we can look above. I have x squared right here. Well, I know that x squared is just 2 x's. Times another x, well, that's 3. 3 x's. So x to the third power. Kind of cool. There's a neat trick to it that I'm going to show you here in a minute. But maybe I'm going to see if you guys can kind of discover it. What about x squared times x squared? X to the fourth power. How did you get x to the fourth power? Not necessarily. That is a really good way to look at it here, but yeah, you're adding them. Because x squared is x times x times x squared, that's another x times x. You're going to have x times itself 4 times in this scenario to get x to the fourth power. Now let me show you one more. This one can be confusing because 2 plus 2 is 4 and 2 times 2 is 4. Let me show you one where the answer is a little different. What about x to the second power, so x squared, times x to the fourth power? X to the second power times x to the fourth power. X to the sixth power. Why is it not x to the eighth power? You're adding the exponents. 2 plus 4 is 6. This feels weird because we're multiplying. But let's think about what each of these means. X squared means, let me write this in a separate color. X squared means x times x, right? X to the fourth power means x times x times x times x, 4 times. For however many x's we're multiplying, that's the number of our exponent. How many x's are multiplied here? 6. So x to the second power times x to the fourth power is x to the sixth power. Kind of cool. I think it's neat just to see it all written out like that. That is pretty cool. How about I give you another one? Let's try x to the 15th power times x to the 30th power. X to the 45. Yeah, x to the 45th power. You're just adding the numbers. That's your quick and easy trick. X to the 15 times x to the 30. 15 plus 30 is 45. Huh, pretty cool. Okay, how about another one? How about x to the 527th power times x to the 21st power. Yeah, x to the 548th power. And all we did to get here is x to the 527 plus 21. And that's how we got 548. Same with 15 plus 30. That's how we got 45. I think it's kind of neat. So, whenever we want to multiply exponents, we add the numbers. Now, one way that might help us remember when we have something, for example, like x squared times x, it's the same thing as when you don't have a number in front of the x. If there's not a number for the exponent, there's an invisible 1. That way I can do 2 plus 1 is 3. 1 plus 1 plus 1 plus 1 is 4. 1 plus 1 plus 1 is 3. 1 plus 1 is 2. We see that? Kind of cool. So if you wanted a formula for this, there is technically a formula. If this confuses you more than it helps you, don't worry about writing it. Some people love it, some people despise it. The example we're given is x to the a power times x to the b power equals x to the a plus b. This is your formula for multiplying exponents. So to multiply, we add. Write that as well. Okay. Now, I bet you the next thing we talk about, you'll get it really quick because it's very similar to this. Can I move this page? Anybody still need it? Okay, I'll wait. Thank you for speaking up. I will pause my recording for a moment. Okay. So I'm going to go ahead and go to what will be my page 3. Now, the last thing we need to talk about before we move on is exponent division. Now, most times out in the wild, you'll notice you never see the division symbol ever. It's like it doesn't really exist. Division is almost always written as a fraction, okay? So I'm going to teach it to you with fractions because that is how you will see it. So let's say I have x to the 5th power divided by x to the 3rd power. X to the 5th divided by x to the 3rd. So before we talk about the rule, I'm going to help us visualize this and show exactly what we're doing. X to the 5th power really means x times itself 5 times. So I'm going to start by writing out x 5 times. 1, 2, 3, 4, 5. Okay, there's my line. And x to the 3rd power is x times itself 3 times. So x, 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 3 x's. You know how whenever we are solving equations, if I have a number over the same number, it cancels? The same thing works for variables. I can cancel these x's, they have a pair. I can cancel these x's, they have a pair. I can cancel these x's. Yes, I have 2 x's left, so my answer is x to the 2nd power. They cancel out. Yes, yes, we're subtracting. You can also say 5 minus 3 is 2. I think it's really cool. Really cool. Okay, let's do another one. How about, let's do, I'm going to give myself a little more room. X to the 10th power over x to the 6th power. A great way to help yourself is to draw out the x's. Now, when you start getting to huge numbers, that takes a long time. I'll draw the numbers out first, or draw the x's out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over x to the 6th. I've got 6 x's here. 1, 2, 3, 4, 5, 6. We could cancel out our x pairs. This took a while though, okay? Let's see. I've got, there's a pair, 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 there's a pair. X to the fourth power. I've got 1, 2, 3, 4 x's left. So it would be x to the fourth power. The other way we could do this without having to draw all of our x's out. Yes, this is the same as 10 minus 6, 4. So let me write that out a little bit better over here. This is really just x to the 10 minus 6. And that's how we get our 4. This one was x to the 5 minus 3. That's how we get our 2. Let me do another one. X to the 347 divided by x to the 132. All right, work that out and tell me if you can find the answer there. Ooh, I didn't even work it out yet myself. Let me check it with my calculator. I'm sure you're correct. Sweet. 347 minus 132 is 215. Very nice. That's all we did. X to the 347 minus 132. And we got x to the 215th power. Not so bad, is it? Y'all got this. Y'all got this. What if I start throwing coefficients in there? Do you know what a coefficient is? A coefficient is a number in front of a variable. So if I had like 5x squared, 5 is my coefficient. Yes. Coefficient. Coefficient. So let's say I have 5x squared divided by x. Yes, it would. So we know that here in front of our x and above our x, there's no number, so I could assume that there's one x, and I can assume that it's x to the first power. So 5 divided by 1 is 5. X squared divided by x to the first power is x to the first power, which is also just x. And that's our answer. If we wanted to visualize it, we could also do that. 5x squared, 2 x's, divided by x. You see that? Our x's cancel, giving us 5x left over. That's our answer. Yeah, I just worked it out another way, just to show that that's what we did. We got it, though. We got it. Okay, let's do one last example for this. Now let's do something tricky. 48 x to the 10th power divided by 6x to the 6th power. Very close. 8x to the 4th power. Yes. So how did you get that? Yes, so 48 divided by 6. 48 divided by 6 is 8. And then x to the 10th power divided by x to the 6th power is x to the 4th power. Good. So our answer is 8x to the 4th power. We just divided our big numbers first, our coefficients. Then we divided our exponents, and we got our answer. Okay. Before we move forward, do we have any questions at all about anything we just did? Or is everybody feeling okay? Any questions? Okay, okay, okay. I gotcha. So, whenever we're looking at stuff like this, what do you think, whether you are having a hard time or you are thinking of what may be a hard time for another person? What do you think might be one of the most difficult parts about doing something like this? I want to think about what might be the hardest part of this type of problem.
I don't know if this is like an actual thing that comes later or not. My brain though, like with the 5x squared, my brain keeps wanting to do 10x, like multiplying the like 5 into itself.
Oh, yeah. I see. Okay. So another thing that I think might be hard is you see like 5x squared. Do you think anybody in here might accidentally do 5 squared instead of squaring the x? It could happen. Or like the 5 times 2, like you said, the 10x maybe. Absolutely. And you know what? I think one of the best ways is more practice to get better. And I think in math, that's just how it ends up being, is we just do more and more, and then we get better and better, and it gets drilled into our brain. It's just how it works sometimes. So here's what I would like us to do. I'm going to give you a few multiplication problems and division problems to try on your own, and then we'll go over them together. And I'm going to give you quite a bit of time to do this. So I'm going to write a bunch out. Let me just title my page first. Now go back, and we just took some really good notes, guys. We have lots of guides to help us look back at what you wrote, and that will help you solve these if you lose your way for a minute. And Titania, after I write these problems down, I'm sure you were taking your quiz. Do you want copies of the notes we took, or did you? Okay, perfect. Okay. And I'm happy to make more copies for anybody else that may want them. Okay, this is page 4. And these are kind of small. I'm happy to make a copy of this as well if anybody wants it here in a minute. I'm just going to write some out first. And here's a challenge one. All right. Would anybody like me to make them a copy of this so that you don't have to write them all down and squint your eyes? Okay, let me do that now. I'm going to freeze my screen in case anybody is just writing it themselves. And I will be right back. Okay. Pause this recording. So you all just had some minutes to do these on your own. Let's see what kind of answers we got. For number one, what did you guys get? Shout some out. X to the 37th power. Did anybody get something different? We all got it? That is correct. 32 plus 5 is 37. X to the 37th power. Very good. Number two, 3x to the 10th power times x to the 12th power. What did we get? Yes, 3x to the 10 plus 12 is 22. 3x to the 22nd power. Very nice. Okay. Now, number three. What do we get?
30 to the 21st power.
So, how do we get 30x to the... Yes. 5 times 6 is 30. X to the 12th times x to the 9th. Well, 12 plus 9 gives us 21. 30x to the 21st power. Very good. Okay, so there were 3 multiplication. Now we've got some division. Number 4, 3x to the 5th power divided by x to the 3rd power. What did we get? Yeah, 3x. 5 minus 3 is 2. 3x to the 2nd power. Very good. Okay. How about number 5? 3x to the 8th power. How do we get 3? Yeah, 15 divided by 5. We divide our whole numbers first. Then, this is where it gets tricky, is remembering to go from division to subtraction. Same with on number 4, or not number 4, number 3. Going from multiplication to adding to multiply, that can be tricky. That can be tricky. But whenever we have just regular old numbers, we divide like the regular old division. When we get to exponents, that's when we switch it up. So 10 minus 2 is 8. That's how we got 8th power. 3x to the 8th power. Okay. Number 6. Yes. 4 over 12 can be simplified to 1 over 3. And then our x's be 1x to the 2nd power. Now, this one was a little tricky. Okay. So let's walk through this one. Absolutely. So whenever we have a problem where there's whole numbers, variables, and exponents, it's really good to take a step-by-step approach. We're always going to look at our whole numbers first. 4 over 12. Okay, so I'm going to pull this whole problem out to the side. 4x to the 3rd power over 12x. And I'm just going to zoom in real big. So I have 4 divided by 12 first. Now, an issue that you may have run into is if you do on your calculator, 4 divided by 12, you're going to get a decimal, 0.3 repeating. What could we do in this situation? Yes, we can flip it and think of it more as 12 divided by 4. Let's try that. 12 divided by 4, which is 3. Now, since we did it upside down, not -3.
The 3 will be at the bottom, the 1 will be at the
Yes. Then, since we did 12 divided by 4 instead of 4 divided by 12, that 3 ends up at the bottom of the fraction, okay? Because here's what we're really doing. 4 divided by 4 and 12 divided by 4. 12 divided by 4 is 3. 4 divided by 4 is 1. We just simplified a fraction, basically. 4 over 12 is the same as 1 over 3. We simplified. So we have our whole numbers simplified. And how do we do x to the third power divided by x?
3 minus 1.
Yeah, we're remembering that if there's not a number here for our exponent, we always assume there's an invisible number 1. Since it's an exponent and not a regular number, we're subtracting to divide. 3 minus 1 is 2. So we have x squared, x to the second power. Okay, so we really did 2 different steps. 4 over 12 gets us 1 over 3. X to the third divided by x to the first. 3 minus 1 is 2. It's a little tricky, but we do get there. This would be our answer. And Kelsey, I bet you're thinking, can I write x squared? Yes, you can. You don't have to write the 1. You could just write x squared over 3. Absolutely. Okay, do we have any questions about that one? Any questions at all? Okay. Can we look at number 7, the last one? Okay, so here we kind of combined what we've been doing with our distribution. Now I have 3x times the quantity inside the parentheses, 5x plus 6x to the third power. So how would I go about simplifying this? What would I do? We're distributing. I'm going to take 3x times 5x. Okay, and I'll bring down that plus sign. And then 3x times 6x to the third power. So, what is 3x times 5x?
15 to the second power.
Yes, 3 times 5 is 15. X times x is x squared, or x to the second power. We have 1x and another x. 1 and 1 is 2. Okay, so we got there. I'll bring down my plus. And now I have 3x times 6x to the third power. So first, what is 3 times 6? 18. And x times x to the third? X to the fourth. There's an invisible 1 here.
Okay, I was going to say, wait a minute now.
Yes. So same with how we got 15x squared. We have these 2 x's here. It's like there's an invisible 1 above them. 1 plus 1 gives us 2. 1 plus 3 gives us 4. And that would be our answer. I know that's tricky. That would be our answer. Pretty good. Pretty good. Okay. Now, I'm debating in my head where I want to take you guys today because I think what we will do now is we've done a lot of review. I would like to give you an exit ticket only because I have at 3 o'clock an appointment that I have to go to. So I would hate to be rushing out of here if y'all need help with anything. So what I'm going to do now is I'm going to create your exit ticket, and it will be 2 questions. Sounds good. Sounds good. And I will make copies of it for you all, but this is going to be it for today. We're not going to have a second half of class just because I do have that appointment. Yes, so let's write that out. Algebra 1. And this is the last exit ticket for this week.
How many more weeks we got left?
Well, we are on week 5. Yeah, 6, 7, 8. Technically 3 more weeks. Yes. But the last week is just finals week. So really 2 weeks and however long it takes you to take the final. Okay, so this will be your exit ticket. If you decide to write this on your own, just make sure that you write that it is day 19. And this will be due on Friday. Okay. So I want you in this exit ticket to simplify each expression. That's what we just did. It's just written in fancier words. Okay. So for number 1, and that's it. These 2 questions, when you finish them, you are free to go. I will make copies though, as I said. You're welcome. Hang on. You're welcome to, there it is. You're welcome to wait for the copies, but if not, you're also more than welcome to go ahead and start working on that. But that is all today, so the end.